Hi, Akram. I just responded to your question on enthalpy, and agree with you on the first point, right? So in the question paper it says kilojoules, and like you rightly say, it should be kilojoules per mole. So that's good. The question 14.3, because in the reaction 2 moles of water are formed, not just one, right? So this is a good question. Let's go through it. I think the question in the mark scheme is correct, so let's go through it and see why. Okay, so while you were working through question, the early parts of the question 14, you would have worked out the moles that are reacting, right? So you could have chosen sulfuric acid or potassium hydroxide. It didn't matter because they're stoichiometrically they're the same, right? So let's say you worked out potassium hydroxide moles. So the moles of potassium hydroxide would be your volume times your concentration, and that came out to be 0.084. All right, and you know, if you'd done it with your sulfuric acid, you would have got 0.042 moles. So let's just write that in for completeness. So if you'd done that with sulfuric acid, you would have got 0.042, right? But because of the molar ratios in the balanced equation, these are stoichiometric, meaning that there's no excess reactant, there's no limiting reagent. They're reacting stoichiometrically, so that's good. Doesn't matter which one you use, right? So then you refer back to the balanced equation. You have to work out how many moles of water that you generated, all right? And you see that the molar ratios for water and potassium hydroxide are both 2, right? So the moles of water is the same as the number of moles of potassium hydroxide, which is 0.084. So now you've got that many moles. Now then you, in an earlier part of the question, you've worked out Q from MC delta T, and that's come out to be 4.828 kilojoules, and that has been generated, right? So this heat was generated, right, by making 0.084 moles of water. That's what we worked out, and then what we do is we're asked for the enthalpy change of neutralisation, like so, and like you quite rightly said, that's the energy to form 1 mole of water. So the energy to form 1 mole of water, all right? And despite there being 2 moles of water in the balanced equation, all right, when we work it out, we go Q over N, all right, and the Q is your 4 point, so we'll put a minus in there now because it was exothermic, and we need to take account of that for delta H. 4.828 kilojoules divided by, right, 0.084, and that is going to give you the energy required to make 1 mole of water, right? Because you're dividing it by 0.084, right? So, and 4.828 is the amount of energy to make 0.084. So that is going to give you the amount of energy, minus 57.5 kilojoules, right, to make 1 mole of water. All right, because you divided it up by 0.084, and by doing so, you get the amount of energy to make 1. Okay, so that number of minus 57 is the amount of energy that's required to make 1 mole of water. Nice question.